Hello everyone, welcome back to my YouTube channel. So today my topic for this particular video is Deepseek R1 model. I'm going to deploy Deepseek R1 model on my local machine. So let me start. So recently we see lot of hype related to DeepSeek R1, like the lot of people compare DeepSeek R1 with the OpenAI O1 model. So DeepSeek R1 basically the reasoning model, and this developed by the DeepSeek startup. And let me first discuss the few things related to the DeepSeek, like the some features related to the DeepSeek, and then we are going to deploy this R1 model. First, let's start with the DeepSeek R1 basic, like the introduction regarding the DeepSeek R1 model and their workflow, like how the reasoning, how the chain of thought is processes work in R1, how R1 basically generate the response by using the chain of thought process, and then move to the deployment part. And I'm going to use this blog, like the DeepSeek R1 for beginner, to showcase you all the steps regarding the deployment of R1 model locally. And in this particular video, I'm going to use the Ollama framework to deploy this R1 model on the local machine. So let me start. So before jump to the deployment part, so let me first explain the DeepSeek R1 quickly from the beginner point of view, like what is DeepSeek R1 model. So this is basically a reasoner model developed by the DeepSeek company, and this basically use the chain of thought process to improve the quality as compared to the general language model. Or if we talk about the traditional model like the llama gpt or any model, the model basically generate the data as per our query, as per their training data. Like we trained our language model on certain amount of training data, and based upon their data distribution, those model basically generate the data directly. Like we ask a query to a language model, and language model generate the data as per the query, as per their training data, like the as per their learning. But here one thing added by the DeepSeek is the chain of thought. So this model basically used query, like we ask to DeepSeek model R1 model to do any task. We ask any query, then this model use the chain of thought process for the reasoning. So this basically improve the quality of the final response. And so chain of thought basically we call is COT. So after the COT process, it return the final response. So as mentioned here, like the DeepSeek R1 model first generated detailed reasoning process through the COT, and then generate the final output. So there is the magic behind the reasoning part, like it used the chain of thought process to generate the high quality of data. So this model basically work in multiple steps. So in intermediate step, it basically think first, like the think through the problem, and then divide the complex problem into the small steps, like number of steps, and then do the this chain of thought process, and then give us the more accurate answer. So here are the key feature of DeepSeek R1 model. First one is the chain of thought, COT. We call the chain of thought reasoning, or we also call it COT reasoning. So DeepSeek R1 generate step-by-step reasoning process before producing the final answer. So this is not a simple language model. Like if we talk about the traditional language model, those model basically generate data as per their training data, as per the query. So we ask any query to language model, and language model return the response, like generate the response directly based upon the query and based upon their training data. But these DeepSeek R1 model use the chain of thought reasoning. It basically divide the complex problem into the number of step, and then do the reasoning step by step by using the COT process. And after the all COT process, like all step is done, then retrieve the final response, like then generate the final response. So as we know, the R1 model use the COT process. So COT content also accessible through the API. We can access the COT content as well. along with the final response. So second thing is the context length. So in case of context length in R1, there is the two context length. First one is the simple context length of the model, and is its API support the 64K token context limit. This is similar to the other language model, like every language model has the context uh, length, so it has the 64K token, so that it handle the large or the long context complex query easily. This is similar to any other model like the context length. But there is the another thing, there is the COT process. So for the COT process, it has the separate 32K token length. So 64K overall context length, this is separate. In for the reasoning part, for the reasoning capability, reasoning process like the chain of thought process, it has the separate length 32K token. And next feature is the multi-round conversation. So in case of chatbot, like suppose you develop your chatbot by using the R1 model, so there is the multi-round conversation. So in case of multi-round conversation, the COT of the one round, like the previous round, is not carry forward to the next round. So suppose you ask question to your R1 model. So R1 model first do reasoning by using the COT process, and then generate the best answer as per the reasoning, as per the COT process. So this is the, for example, this is the turn one, you ask the first question, then you ask the second question. Here this is the second question. So in case of long conversation like the multi-round conversation, it like the COT of the previous round, you can see here, this one the COT of previous round, this is not carry forward to the next round. As mentioned here, like the COT of previous round is not carry forward to the next round. As seen here, you can see here COT is missing, COT is not carrying forward. So this is the second question. Then again the COT process is uh, run again, like the R1 model execute their COT process to generate the best model to do the reasoning. And so it basically focus on the latest query to generate a more accurate, more meaningful answer. And based upon the COT, it basically generated the answer. So in the third round, this is the question one and answer for the question one. This is the question two, answer for the question two. Then in the third round, let's user ask the question three. So you can see here the COT of question one is missing, COT of question two also missing. So this way basically it start a new chain of thought process to generate the more meaningful answer as per the question third, and then generate the answer. So this way multi-round conversation basically work in this R1 model. So next feature is the API integration. Similar to the OpenAI, Deepseek R1 also accessible through the API, and you can integrate this API with your application and directly use this. And here are the price detail in USD, in US dollar. These are the price detail, and these are the Deepseek chat API. This is the Deepseek reason model, like the R1 model API, and these are the context limit, and these are the maximum number of token in the COT process, and this is the maximum output. This is the token for the maximum number of token generated through the output, and this is the price. If you want to integrate the Deepseek API with your application, similar to OpenAI APIs, but I'm going to show you how you can deploy this R1 model on your local machine. In case of deployment on local machine, then we don't require the API of R1 model. So before going to the deployment part, let me explain you like how these Deepseek R1 is work. So if we interact with Deepseek R1 model, so it basically follow the two-step process. First one is the generating the COT. COT means chain of thought. So this model first generate a detailed reasoning process by using the COT to break down the problem into smaller, like the smaller steps or the logical step, you can say the smaller and logical step, and then solve this problem. And these all COT process data stored in the reasoning content, we can access these through the API, and then it produce the final answer. So based upon the COT, model generate the final answer and it store under the content field. So there is the two field. One is the content store the final output, final response, and reasoning content store the COT process data. So there is the two things here. And further there are the few parameters, API parameters we can use for the DeepSeek R1. First one is the max token. So this is the maximum token for the output, for the final response, like we can control the final response by using this max token parameter, and default final token is set to the 4k, and we can set up to the maximum 8k token, and this is separate from the context length. Context length again is 64k, similar to any other language model, and COT COT output length is 32k, and this max token basically control the output, like the final response length. Final response length is up to the 8k token, and default set to the 4k token. Then the reasoning effort, we can control the COT output, like the COT output we can control by using this reasoning effort feature, and this also coming soon as per the data available on the DeepSeek website. And further the output parameter, this one parameter is the reasoning content. This reasoning content basically store the COT data, and the content parameter store all the final response. So these are the parameters of DeepSeek. Further, the important note here that this API, DeepSeek API, is currently is not supported the temperature, top P, top K, this kind of parameters. And now I move to the supported feature. So DeepSeek API is support the chat completion, chat prefix completion. This is the beta version, and not supported the function call and JSON output. So before going to the deployment part, let me show you some comparison of DeepSeek accuracy with other models, DeepSeek performance. So this blue bar for the DeepSeek R1 model, and the gray one for the OpenAI O1 model, and this one the DeepSeek another variant like the 32 billion model, and this is the OpenAI O1 mini model. So main comparison between the DeepSeek R1 and OpenAI O1, this is the main comparison between these model. And you can see here most of the cases the DeepSeek R1 is beating the O1 OpenAI O1 as per the data available on their DeepSeek official website. This is the data available on their official website. So now I move to the deployment part. So for the deployment, I'm going to use the Ollama framework. Ollama is the framework available to deploy the language model on the CPU on the low configuration machine. So here basically I'm going to deploy this model on the 8 GB laptop. Further, if you have the 16 GB laptop or more than 16 GB, then you can deploy 8 billion parameter and more model as well, like the more big model as well. So here are the model available on the Ollama website. So this is the Ollama official website. This is the Ollama official website, and you can see here the DeepSeek R1, and DeepSeek R1 there is the 1.5 billion model, 7 billion, 8 billion, 14 billion, 32 billion, 70 billion, and 671 billion. These are the model available on the Ollama website, and I'm going to deploy very basic model like the 1.5 billion. But if you have the 16 GB RAM or more than 16 GB, then you can try with these three model as well. First you can try with 7 billion and 8 billion, then you can go for the 14 billion as well. So let me back to the blog link, and further I will provide all the links like the blog link, code link, and website link in the description of the video as well. So these are the hardware requirement, like the minimum hardware requirement to deploy Ollama framework and to deploy our DeepSeek model. Like I'm going to deploy on the Windows machine, but you can deploy on Mac as well, Linux as well. So first things is we need to install the Ollama. You can directly download the Ollama from the Ollama GitHub repository, and you can install easily by using the instruction available on the Ollama website. And once the Ollama is installed, then you can go to the CMD and run this Ollama version command. You can see the version of the Ollama. So once the Ollama is installed on your machine, then you need to run this command, like the Ollama pull Deepseek R1, and here are the parameter of the model, which model you are going to download. So this command basically to download model on your local machine, pull command. So here I'm providing the 1.5 billion. So this way basically this command is run Ollama pull Deepseek R1 1.5 billion. So you can see here size of the model is very less, like the 1.1 GB. And once this download is success, then you can run this model locally on your machine, and you can check the availability of model on your machine with Ollama list. This basically print the list of the available model on your machine, local machine, and this is the command to run your model locally. Ollama run DeepSeek R1, and then you can ask any question. So let me open the CMD and run this command. So this is the CMD, and I'm going to run this command Ollama run DeepSeek minus sign R1 and 1.5 billion. This way your model is run on your local machine. Now this model is loading. Yeah, it's working. So now you can ask any question. So this is the question I ask, like the A train leaves Agra at 5 a.m. and reach Delhi at 6 a.m. And then we have another train leaves Delhi at 7 a.m. reach Agra at 10:30 a.m. And between the distance between the Agra and Delhi is the 28 kilometer. So now my question is, at what time the trains cross to each other? So this is the like the reasoning question. So let me ask this. So this is the chain of thought process as shown here. This is the reasoning. This data, like the think data, basically contain the COT process data. This is the think data. So now this model is working, and this is thinking. You can see here, this whole process is the chain of thought process. Before generating the final response, this model is using the chain of thought process. So first this model is calculating the speed of the train. You can see here speed of that first train and second train. You can see here the multi round of chain of thought. You can see here this is the first round of chain of thought, and then it again going to calculate the speed of the train and the distance traveled by the train, all the things. So it generates the response, and as I mentioned, like it is the very small model. I deploy 1.5 billion, which is a very basic model. So the answer is not correct, and it also mentioned like available option is not match as per the reasoning process. But you can see here, like the before generating the response is do lot of reasoning, lot of think before giving the final response, and then give us a final answer. So if we ask the same question to Deepseek R1 through the UI part, like the chat.deepseek.com, so it give us the right answer. So you can see here we ask the same question here. This is the same question, but first thing it basically calculate the speed of both the train, and then it basically calculate the cross time, and before the cross time it basically discover the discover the distance covered by both the train. And you can see here, after all the reasoning, it basically calculate the accurate time like the 7:56 a.m. So correct answer is the 7:56 a.m. on which both the train cross each other. D option basically. And now I back to the deployment part. So once our deployment is done on our local machine, then we can use the Ollama APIs as well to integrate with our application, and we can develop our own RAG system also. So here basically I'm use the code from my previous tutorial related to the RAG system. Here basically I'm developing RAG by using the LlamaIndex. LlamaIndex is the integration framework to develop the RAG system, and the Flask API for the UI part. And here I'm using the Deepseek R1 model again by using the Ollama wrapper. Ollama from here from LlamaIndex. You can see here. Here LlamaIndex provides us the Ollama wrapper, and I'm loading Deepseek R1 model by using this wrapper. This way basically I'm developing the RAG application by using the DeepSeek R1 model. So this way you can try multiple things, and all the links related to the code, like this is the GitHub code. This is the GitHub code. I will provide all the link like the GitHub code, this blog link, and Ollama website, DeepSeek website, all links in the description of the video. And further in the next video I'm going more deep into the DeepSeek R1 and V3 model. So thank you for watching this.